do waves behave? Badly? In this video, we are going to look at how light and sound waves behave. Before we start, you should know that waves can be transverse or longitudinal. Transmission, reflection, refraction, diffraction, absorption, and scattering are all typical wave behaviors. Reflection is when waves bounce off an object. Sound waves are reflected by hard, flat surfaces and is why we get echoes. You hear a delay between the original sound and the echo because the echoed sound waves have to travel twice as far to reach your ears. Smooth surfaces, like glass and polished metal, reflect light in a regular way, so a reflection can be seen. Like a mirror, or seeing your face in a calm pond. Transmission is when waves keep traveling in the same direction through an object, like light through a window. Absorption and reflection often go hand in hand for light waves. White light contains each wavelength, so all colors of the visible light. The color of an object depends on which wavelength of light it absorbs and which it reflects. White objects reflect all the light that hits them and absorbs none. Black objects reflect none and instead absorb all the light that hits them. A red object absorbs all the wavelength except red, which is reflected. And a green object absorbs all the wavelength except green, which is reflected. Are the new people upstairs really noisy? If they carpet their floors, add curtains and furniture to the room, then you'll notice that they become much quieter. This is because some objects absorb sound waves. When light and sound waves pass across the boundary between two substances, like air and glass, they change speed. This is because the substances have different densities. The change in speed causes the waves to change direction, which is known as refraction. Because of refraction, things in water look closer than they really are, and water appears shallower than it really is. And a straw in a glass of water looks like it bends at the surface because the refracted light wavelengths make you think that the straw is in a different place to where it actually is. When waves meet a gap in a barrier, they pass through the gap. Then they spread back out after they pass through the gap. This is diffraction. The way the waves respread depends upon how big the gap is compared to the incoming wavelengths. We have diffraction to thank for loudspeakers. Sometimes waves depart from the expected path and spread out in multiple directions. This is known as scattering. We have scattering to thank for making the sky appear to be blue. The white light coming from the sun hits the molecules in our atmosphere, which cause the shorter blue wavelengths to scatter out in all directions. So waves behave in a variety of ways depending upon what material they hit.